process where we apply systematic protocols, proper controls to research designed to help us overcome our inherent biases and incorrect conclusions that we often draw from different phenomena that happen or different experiences that happen to us in life. So what does empirical mean? It's essentially a source of knowledge acquired by means of observation or experimentation. So observation can simply mean by looking at how things naturally emerge in the real world. Correlation is a really common method of observational research. You might look at the relationship between, whether people play violent video games and the number of aggressive acts that they exhibit while they're playing these violent video games. And that might be one type of observational study that you might do. But there are really a whole host, whether people watch happy movies, is that related to them being happier in real life and so on. And that might be an observational type study. An experiment is different. It's essentially where we break people into groups and give one intervention, or we manipulate the real world in some way for one group, but not for the other group. And that's known as an experiment. And that's a very different type of research that has different strengths and limitations to the observational type research. So that's essentially what we mean by empirical. So what is research? This studious inquiry or examination, especially, this is another dictionary definition, investigation or experimentation aimed at the discovery or interpretation of facts, revision of accepted theories or laws in light of new facts, and practical application of such new or revised theories or laws. So we investigate certain phenomena, we uncover facts, we try and interpret those facts in some way. Usually we interpret them through theory. A theory or a theoretical framework often provides us with a particular model that we think explains the real world and that can help explain relationships between these facts that we uncover in different types of studies. And then the practical application of new data to these revised theories. So we might find something that contradicts what we think this theory would predict, and we might make a modification to the theory or completely reject the theory based on new information that's become available and so on. And that's essentially what we mean by research. And I'm going to give you several different examples of research. So different examples of researchers that you are probably familiar with. Jane Goodall is one of them. She's a very well-known researcher who's famous for her studies with apes. She came to Australia recently. She's been on shows such as Q&A. She's one person who's very famous for her research. Charles Darwin, obviously, famous for the theory of evolution. Daniel Kahneman, if we're going to choose someone from the field of psychology, Daniel Kahneman is someone who's very famous. In 2002, he won the Nobel Prize for his work in behavioral economics, which is essentially a lot of the information that I took you through earlier about psychological biases comes from the work of Daniel Kahneman, looking at how we make incorrect judgments, incorrect decisions based on different cognitive heuristics that we have to explain the world around us. So he's quite well known. So there's some well-known researchers who apply the research method in their research. When we say the research method or research process, what are we talking about? So essentially we start with a theory, or we generate a theory or research questions, something we want to find out. After we have the theory and we have our hypotheses, those the things that we predict would happen in real life based on how this theory would predict, we collect data to see whether the data matches our prediction and whether it indeed matches the theory. After we collect data, we analyze the data using appropriate statistical tools. We look at whether our predictions have been confirmed or disconfirmed. If they're disconfirmed, does it mean that we have to go back to the theory and make a modification or alteration to the theory? Or is it something wrong with our data? And what might explain why we didn't confirm our hypotheses during the data analysis stage? And then afterwards, we publish our results. So whether we confirm or disconfirm our expectations, we publish what we find and then allow other people, usually other scientists and scholars, to interpret our findings, use it in making their own predictions in their own research studies, conducting their own research, collecting their own data, analyzing their data and publishing it. The process keeps on going until a research literature is built. And when that happens, we have a lot of information on a particular topic that tells us how the world works around us. So the summary, what is the goal? What is this scientific research? So we have a goal, and it's essentially to understand a real world phenomenon. So we want to understand what makes people happy. We want to understand how to help people with depression. We want to understand how to stop people being aggressive and violent, or whatever it might be. We create theories and hypotheses to test based on this research question or this real-world phenomena we're trying to investigate, and then we gather data to test how closely the theory models reality. And if it doesn't model reality based on the data, assuming nothing's gone wrong with the data and collecting it, there is no biases and so on in there, we can make modifications and changes to the theory based on what comes out of the research. So that's the first part of the lecture. This next part is going to be particularly important for your assignment. We're going to look at research methods, so different types of research designs, the problems and limitations with different research designs. How do you actually measure different variables in psychological research? So we'll look at self-report instruments, which a lot of you have probably done through various parts of your life, at school or, even while you're here at university. So let's look at some of those. I'm going to show you videos where possible, just because I think they describe some of these types of different study designs and the advantages and disadvantages nice and succinctly and engaging. So I'll use a lot of videos in this part. Okay, so these are the different study designs. So these are in no particular order, although the order that they're in, it tends to be what comes first in a research process. So generally, these are the types of study designs. So you have correlational designs, you might have qualitative research designs, quasi-experimental designs, experimental or fully experimental with random allocation and so on. And then reviews and meta-analyses is another type of research technique as well. And this is not an exhaustive list, just these are some of the most common types of research you'll find in the field of psychology and education more broadly, and a lot of the social sciences as well. So usually research literatures start with a correlational type of research design, which is essentially, as I referred to before, about exploring and testing relationships between variables. So is there a positive relationship in which the two variables go in the same direction? If the more we drink, the more instances of violent crime you tend to see. That's an example of a positive relationship. So they both go up together. Higher levels of alcohol in a general society is generally associated with higher levels of violence and crime and so on. But you can also have negative relationships. So this is where they move in different directions. If we think about alcohol, again, the more people drink, the less likely they are potentially to be involved in physical activity or sports or whatever it might be. So that might be an example of a negative correlation. So the more one goes up, the less likely the other one is to occur. And that might be a negative relationship. Essential ingredient with correlation is that there's no manipulation involved. So you're not manipulating a variable because we're not doing an experiment. We're just observing natural variables as they occur in the real world and looking at relationships between them. It's a really effective way to do research. Generally, it's a really easy way to do research because it just involves collecting data of natural phenomena around us. And often it's the easiest to do in terms of gaining ethics and so on, because you don't have to change people's reality and so on. The disadvantages of correlation is that it doesn't equal causation. Just because two variables are related doesn't mean anything about whether one variable affects the other. They might do so, but you can't make that conclusion from correlational data. And I'll show you a video which helps explain why.
Like most people, I enjoy a tasty scoop of ice cream, especially Oreo blizzards. But what few people realize is how dangerous a treat ice cream has become. First, there's the issue of obesity. Second, there are higher crime rates. Third, there's the loss of life due to a rise in the number of drowning deaths. And finally, as more ice cream is sold, there's an increase in forest fires. Given these indisputable facts, I need you to support my vision of an ice cream-free world. While banning ice cream trucks from entering your neighborhood may sound far-fetched, when it comes to problem solving, a common issue is misunderstanding the difference between correlation and causation. This misunderstanding can influence our decisions, sometimes with serious consequences that ripple throughout a community. Correlation is when two things are related, but one does not cause the other. Usually this means the two are in some way related to a third factor, but not always. If you have a big enough pile of data, you can find plenty of relationships that are purely coincidental, like the strong relationship between the sale of margarine and divorce rates in the state of Maine. With the sale of ice cream, the third factor is weather. When it is hot outside, people buy more ice cream. They are more likely to go for a swim, and there is a general increase in people out and about enjoying the weather. helping improve conditions for crime to take place, as well as the dry conditions associated with forest fires. A note of caution: there's a growing trend in our digital world called data dredging. This is using analytics to sift through mountains of data, hoping to find useful relationships. Instead of a problem in search of a solution, dredging data is a solution looking to find a problem. All of what I've just discussed about correlations does not mean that finding a correlation is without value. In fact, correlations are a vital part of helping us move to the next step, the discovery of causation. Unlike correlation, causation is when you can claim that one thing causes another thing to happen. In order to make this claim, you need to be able to demonstrate an actual cause and effect relationship, preferably a strong relationship. An example most of us are familiar with is the pharmaceutical industry. In order to make the claim that a particular drug causes a certain effect, such as lowering your cholesterol or growing hair, the FDA requires companies support those claims, putting the drug through a 4-phase, 12-step process that takes approximately 12 years. This process uses control groups and clinical trials to test the drug, making sure that X causes Y and that the drug is safe. The acceptable error rate can go as high as 5% for some drugs, meaning that the clinical trials prove that there's a 95% chance the drug does what it claims. Drugs with serious health implications, such as those used to treat a heart condition, are held to an even stricter standard, requiring proof up to 99% effectiveness. Back to ice cream. What about ice cream and obesity? While it may seem like common sense that it does cause obesity, the fact is that we don't yet know the true strength of the relationship. If we look at the sale of ice cream, there's actually an inverse relationship with weight. People gain weight in the winter when sales are low and lose weight in the warm summer months when more ice cream is being consumed. This might suggest ice cream is the new diet food. Luckily, you now know to be cautious of drawing conclusions of causation from correlation. Instead, recent research on the subject has been looking at different types of sugars used in making a wide range of sweet foods. What scientists have discovered is that the hypothalamus, which is an area of the brain that regulates the human appetite, reacts differently when we consume foods with fructose instead of glucose. This has researchers speculating that eating high fructose foods, such as ice cream, may result in people not feeling full, so they continue to eat. This theory proves difficult, however, when we start considering apples and other natural fruits also contain fructose, not just ice cream and chocolate cake. As you can see, causation is quite a bit different than correlation. Finding correlations is easy, proving causation is hard. No wonder it takes 12 years just to prove that a pill causes hair to grow. The bottom line: on the news, in boardrooms and coffee shops, everywhere you go, you will hear claims that X causes Y. From politics to the weather, from the stock market to personal relationships, it is human nature to try and explain things, to create stories that make sense. Just keep in mind, as you hear a claim of what causes what, that correlation is not causation.
Okay, a really useful video that talks about correlation, why it's used, and some limitations with correlational evidence. Obviously that it doesn't equal causation. So we often hear about in the news or in the media about relationships between certain variables, and a cause and effect relationship is often implied. And a lot of the time that is not justified based on either the study that was done or the available evidence and so on. A common one that you'll often see is if people drink red wine, then they're less likely to suffer heart disease and so on. And that's an example of a negative correlation. So that people drink red wine, then they're less likely to suffer from these different types of diseases. Yet what a lot of that research ignores is that people who drink red wine are also likely to be higher in socioeconomic status, and they're likely to live in wealthier homes and have more money and so on, which is also might be the explaining variable in terms of having less disease and so on. So to make that cause and effect claim, you really have to rule out those types of explanations for the findings that emerge. So that is some of the problems with correlation. Okay, qualitative type of research is another one. So this might be where you interview people or you conduct focus groups, which are small groups of people, essentially asking their opinions or perspective about a certain issue. It helps in potentially formulating hypotheses or developing a deeper understanding of a phenomenon. So if you found a relationship between two variables through correlational study, and you want to understand a little bit more about why that relationship emerged, then you can start asking people about their behaviors that might explain it and so on. So that's more the qualitative type of study. You generally don't have formal predictions in a qualitative study. They tend to be more exploratory, although that's not always the case as well. Quasi-experimental study is a type of experiment, but it's generally done in a real-life setting, and there's usually no random allocation of people into different groups. So if you're conducting a study, I spoke about this previously, about mindfulness in a previous lecture, to determine that mindfulness is a technique that actually leads to better mental health, you'll have to get people into a study, randomly allocate them into a mindfulness group and potentially another group that either does nothing or that does some other variant of training. And you have to be able to demonstrate that the mindfulness group turns out to be better, either in the short or the long term as a result of the mindfulness training that the other group did not receive. And that's an example of an experimental study. A quasi-experimental study is similar to that, except it doesn't use random allocation. Usually it'll observe natural differences between people in the real world. So for example, if you expose children to mindfulness in one school, and then in another school they receive some other type of intervention, that's an example of a quasi-experimental study. So it's kind of an experiment, although you're not randomly allocating people to groups. You're just using the different schools to do that. It's generally less effective than a pure random allocation because there might be some difference between the schools. Maybe one school is higher in socioeconomic status than the other school, and therefore they're more likely to be better off in terms of mental health and so on in the higher SES school than the lower SES school. So that might be one potential explaining variable that you won't be able to uncover if it's a quasi-experiment. An experiment is different in that it's fully manipulates a variable. You give mindfulness to one group but not the other, but it uses random assignment of participants into conditions. So you invite people into the study. Once they accept being a part of the study, then you randomly assign them into a mindfulness condition or whatever it is you're looking at, and you randomly assign another group into a control group, either a control group that receives a different form of training or a control group that receives nothing. You have to be able to show that the intervention you give works in a way that you're predicting based on the available evidence. And that is a really good way to uncover cause-effect relationships. That's different from quasi-experimental designs. So if there are natural differences between the people that have been allocated into the different groups in the experiment, when that random allocation occurs, you expect those differences to be evenly distributed across the two experimental groups. So the real difference that is emerging should be because of the independent variable or the variable that's manipulated. And in the example I'm using is mindfulness. So we're giving one group of participants a mindfulness intervention and another group a different type of intervention or nothing. Okay, and then the last one I've got here is a review and meta-analysis. And it's a review and meta-analysis is opposite to correlational in that it tends to occur after a research literature is becoming more mature, in that there's a lot of research studies that have examined similar topics or similar phenomena. And what a review study or a meta-analysis will do is put all those studies together and statistically combine them to calculate patterns in the data, sources of disagreement between studies, what might explain the disagreement between studies, what are the gaps in the literature, and it'll do that so statistically so you can really see whether there is an effect that is consistent across all the studies and so on. And that's a really useful technique to explore research literatures, particularly after there's a lot of studies within a research literature. So I'm just going to show you a video now on the research process and the research methods, and it'll talk a little bit about biases that we have. It'll talk about different research designs, the advantages and weaknesses of them, and so on. So it'll sort of complement the one that I've already showed on correlation. And it'll do so in a really interesting and engaging sort of way. And it goes for about 10 minutes, but it sort of summarizes a lot of what I talk about and what I'm going to talk about in the rest of the lecture.
Can we cold pizza cause psychedelic hallucinations? Does coffee make you smarter? Or does it just make you do dumb stuff faster? Like bunch of psychology itself, questions like these can seem pretty intuitive. I mean, people may not be the easiest organisms to understand, but you're a person, right? So you must be qualified to draw, like, some conclusions about other people and what makes them tick. But it's important to realize that your intuition isn't always right. In fact, sometimes it is exactly wrong, and we tend to grossly underestimate the dangers of false intuition. If you have some idea about a person and their behavior that turns out to be right, that reinforces your trust in your intuition. Like if I warn my buddy Bob against eating that deep dish pizza that's been in the fridge for the past week, but he eats it anyway and soon starts to wig out, I'm gonna say, dude, I told you so. But if I'm wrong and he's totally fine, I probably won't even think about it ever again. This is known as hindsight bias, or the I knew it all along phenomenon. This doesn't mean that common sense is wrong, it just means that our intuitive sense more easily describes what just happened than what will happen in the future. Another reason you can't blindly trust your intuition is your natural tendency toward overconfidence. Sometimes you just really feel like you're right about people when actually you're really wrong. We've all been there. We also tend to perceive order in random events, which can lead to false assumptions. For example, if you flip a coin 5 times, you have equal chances of getting all tails as you do getting alternating heads and tails. But we see the series of 5 tails as something unusual, as a streak, and thus giving that result some kind of meaning that it very definitely does not have. That is why we have the methods and safeguards of psychological research and experimentation, and the glorious process of scientific inquiry. They help us to get around these problems and basically save the study of our minds from the stupidity of our minds. So I hope that it won't be a spoiler if I tell you now that pizza won't make you trip, and coffee doesn't make you smart. Sorry. In most ways, psychological research is no different than any other scientific discipline. Like, step 1 is always figuring out how to ask general questions about your subject and turn them into measurable, testable propositions. This is called operationalizing your questions. So you know how the scientific method works. It starts with a question and a theory. And I don't mean theory in the sense of like a hunch that, say, a quad shot of espresso makes you think better. Instead, in science, a theory is what explains and organizes lots of different observations and predicts outcomes. And when you come up with a testable prediction, that's your hypothesis. Once your theory and hypothesis are in place, you need a clear and common language to report them with. So, for example, defining exactly what you mean by thinking better with your espresso hypothesis will allow other researchers to replicate the experiment. And replication is key. You can watch a person exhibit a certain behavior once, and it won't prove very much, but if you keep getting consistent results even as you change subjects or situations, you're probably onto something. This is a problem with one popular type of psychological research, case studies, which take an in-depth look at one individual. Case studies can sometimes be misleading because by their nature they can't be replicated, so they run the risk of overgeneralizing. Still, they're good at showing us what can happen and end up framing questions for more extensive and generalizable studies. They're also often memorable and a great storytelling device psychologists use to observe and describe behavior. Like, say the smell of coffee makes Carl suddenly anxious and irritable. That obviously doesn't mean that it has that same effect on everyone. In fact, Carl has terrible memories associated with that smell, and so his case is actually quite rare. Poor Carl. But you would still have to look at lots of other cases to determine that conclusively. Another popular method of psychological research is naturalistic observation, where researchers simply watch behavior in a natural environment, whether that's chimps poking anthills in the jungle, kids clowning in a classroom, or drunk dudes yelling at soccer games. The idea is to let the subjects just do their thing without trying to manipulate or control the situation. So yeah, basically just spying on people. Like case studies, naturalistic observations are great at describing behavior, but they're very limited in explaining it. Psychologists can also collect behavioral data using surveys or interviews, asking people to report their opinions and behaviors. Sexuality researcher Alfred Kinsey famously used this technique when he surveyed thousands of men and women on their sexual history and published his findings in a pair of revolutionary texts, Sexual Behavior in the Human Male and Female, respectively. Surveys are a great way to access people's consciously held attitudes and beliefs, but how to ask the questions can be tricky. Subtle word choices can influence results, results. For example, more forceful words like ban or censor may elicit different reactions than limit or not allow. Asking, do you believe in space aliens is a much different question than, do you think that there is intelligent life somewhere else in the universe? It's the same question, but in the first, the subject might assume that you mean aliens visiting Earth and making crop circles and abducting people and poking them. And if how you phrase surveys is important, so is who you ask. I could ask a room full of students at a pacifist club meeting what they think about arms control, but the results wouldn't be a representative measure of where students stand because there's a pretty clear sampling bias at work here. To fairly represent a population, I'd need to get a random sample where all members of the target group, in this case students, had an equal chance of being selected to answer the question. So, once you've described behavior with surveys, case studies, or naturalistic observation, you can start making sense out of it and even predict future behavior. One way to do that is to look at how one trait or behavior is related to another, or how they correlate. So let's get back to my buddy Bob, who seems to think that his refrigerator is actually some kind of time machine that can preserve food indefinitely. Let's say that Bob is just tucked into a lunch of questionable leftovers, pizza that may very well have had a little bit of fungus on it, but he was hungry and lazy, and so he doused it in sriracha. Suddenly, he starts seeing things. Green armadillos with laser beam eyes. From here, we could deduce that eating unknown fungus predicts hallucination. That's a correlation, but correlation is not causation. Yes, it makes sense that eating questionable fungus would cause hallucinations, but it's possible that Bob was already on the verge of a psychotic episode, and those fuzzy leftovers were actually benign. Or there could be an entirely different factor involved, like maybe he hadn't slept in 72 hours or had an intense migraine coming on, and one of those factors caused his hallucinations. It's tempting to draw conclusions from correlations, but it's super important to remember that correlations predict the possibility of cause and effect relationships. They cannot prove them. So we've talked about how to describe behavior without manipulating it, and how to make connections and predictions from those findings, but that can only take you so far. To really get to the bottom of cause and effect behaviors, you're gonna have to start experimenting. Experiments allow investigators to isolate different effects by manipulating an independent variable and keeping all other variables constant, or as constant as you can. This means that they need at least two groups: the experimental group, which is gonna get messed with, and the control group, which is not gonna get messed with. Just as surveys use random samples, experimental researchers need to randomly assign participants to each group to minimize potential confounding variables or outside factors that may skew the results. You don't want all grumpy teenagers in one group and all wealthy Japanese surfers in the other. They gotta mingle. Now, sometimes one or both groups are not informed about what's actually being tested. For example, researchers can test how substances affect people by comparing their effects to placebos or inert substances. And often, the researchers themselves don't know which group is experimental and which is control, so they don't unintentionally influence the results through their own behavior. In which case, it's called, you guessed it, a double-blind procedure. So let's put these ideas into practice in our own little experiment. Like all good work, it starts with a question. So the other day, my friend Bernice and I were debating. We're debating caffeine's effect on the brain. Personally, she's convinced that coffee helps her focus and think better, but I get all jittery like a caged meerkat and can't focus on anything. And because we know that overconfidence can lead you to believe things that are not true, we decided to do some critical thinking. So let's figure out our question. Do humans solve problems faster when given caffeine? Now we gotta boil that down into a testable prediction. Remember, keep it clear, simple, and eloquent so that it can be replicated. Caffeine makes me smarter is not a great hypothesis. A better one would be, say, adult humans given caffeine will navigate a maze faster than humans not given caffeine. The caffeine dosage is your independent variable, the thing that you can change. So, you'll need some coffee. Your result or dependent variable, the thing that depends on the thing that you can change, is going to be the speed at which the subject navigates this giant corn maze. Go out on the street, wrangle up a bunch of different kinds of people, and randomly assign them into 3 different groups. Also, at this point, the American Psychological Association suggests that you acquire everyone's informed consent to participate. You don't want to force anyone to be in your experiment, no matter how cool you think it is. So the control group gets a placebo, in this case decaf. Experimental group 1 gets a low dose of caffeine, which we'll define at 100 milligrams, just an eye-opener and like a cup of coffee's worth. Experimental group 2 gets 500 milligrams, more than a quad shot of espresso dunked in a Red Bull. Once you dose everyone, turn them loose in the maze and wait at the other end with with a stopwatch. All that's left is to measure your results from the 3 different groups and compare them to see if there were any conclusive results. If the highly dosed folks got through it twice as fast as the low dose or placebo groups, then Bernice's hypothesis was correct and she could rub my face in it saying she was right all along, but really, that would just be the warm flush of hindsight bias telling her something she didn't really know until we tested it. Then, because we've used clear language and defined our parameters, other curious minds can easily replicate this experiment and we can eventually pool all the data together and have something solid to say about what that macchiato was doing to your cognition, or at least the speed at which you can run through a maze. Science. Probably the best tool that you have for understanding other people. Thanks for watching this episode of Crash Course Psychology.
Okay, so a really good video that sort of explains a lot of what I've been talking about with the different types of research designs and the different types of ways of doing research and the different biasing factors that we have and why we need to do research in the first place. So this is a hierarchy that's been developed by the NHMRC, which is a part of the Australian government, the National Health and Medical Research Council. They do a lot of medical research or fund a lot of medical research between Australian researchers and other people, or Australian people and overseas collaborators and so on. And this is the hierarchy in terms of them suggesting what's the best type of research method that gives us the strongest types of evidence to evaluate whether an intervention is effective. So if we want to give someone a type of intervention to improve their well-being or whatever it might be, what are the best types of evidence to assess them? So they talk about systematic review as being the top of the hierarchy. So a systematic review is essentially, and it's often combined with meta-analysis, which is what I went through on the previous slide, in that you combine all of the studies that have been done on a particular topic. You systematically search for all of the studies that you can possibly find. So it might not be all of the published studies, but you also include unpublished studies. So these might be studies that governments have done or that organizations have done that have no desire to publish in academic journals. You might look at PhD students and what they've done in their research that they haven't published and so on. And try and get all of that, because the more information you get, the more comprehensive the review is and the more comprehensively you can answer whatever question you're trying to answer.